Question number 9. If y equals to x minus 1, the very first thing that if it is set to f of x, replace f of x by y. In the prerequisite, the very first point was that if the given expression is set to f of x, we're going to replace f of x by y. But the given expression has already been set to y, so we don't need to talk about the f of x. It is y equals to x minus 1. The second point was to replace all the x variables by y and all the y variables by x. So I can write x equals to y minus 1. Look, why we replace x by y and y by x? Because we are talking about the inverse function. We already know that for the inverse function, the x and y values are reverse. The x values for the original function will be the y value for the inverse. The y value for the original function will be the x value for the inverse. We have replaced x variables by y and y variables by x. Now the third stage was to set the equation equals to y. Now the third stage was to solve for the y. It will be y equals to x plus 1. What is meant by solve for y? It means that your final question must set equals to y. Bring this negative 1 to the left side to become x plus positive 1. So I will have y equals to x plus 1. The last stage was to replace y by f of x inverse or by y inverse. But let me replace y by f of x inverse or y inverse. It is up to you. Whether you replace this y by f of x inverse or by y inverse, f of x inverse is the indication of the inverse function. Y inverse is the indication of the inverse function. This is my inverse function, y equals to x plus 1. This is going to be my inverse function. So there I got the inverse function from the given equation. The equation has been given. We replace all the x variables by y and y variables by x, and then we solve it for y. There I got the inverse function. So the notation for the inverse function is f of x inverse. This is the notation for the inverse. Just replace this y by f of x inverse or y inverse, which is just the notation of the inverse function. There I got the inverse function f of x inverse equals to x plus 1 from the given equation. Let me do a simple check. The check is that my given function is x minus 1. Its inverse function is x plus 1. Let me take the composite of the inverse function. At the end I will get x. The moment you get the answer for the inverse function from the equation, that is a simple check. Look, my given function is x minus 1. Y equals to x minus 1. Can I replace y by f of x? So whether you put y or f of x, it is one thing. Just put f of x for y. So f of x is my given function, which is x minus 1, and its inverse function is x plus 1. F of x to the negative 1 is my inverse function. Look, this is not the power. Negative 1 is not the power. It is just the indication of the inverse of f of x. Take the composite of the inverse function with the given function, f composed with the inverse function, which means that you put x equals to x plus 1. What is the value of f of x inverse? The inverse function value is x plus 1. So just plug in x plus 1 for the value of x in the given function. So I will have x plus 1 for the x. So x plus 1 minus 1 plus 1 minus 1 will be 0. So I will have x equals to, so I will have x. So the moment when you get x after composing the functions, then it means that your question is right. Your answer is correct. But if you fail to get x at the end, it means that your answer is wrong. So you can do this composite check for every question. At the end you must have x. So the moment when you get x, you have to be satisfied that your answer is correct.